So now for the next problem, I'm going to find the Laplace transform and the R of C of this given signal, that is x of t is equal to minus e raised to minus at u of minus t. Okay, so first I write my Laplace transform equation. L of x of t is equal to integral minus infinity to plus infinity x of t into e raised to minus st dt. Okay, now I'm going to substitute the given x of t into this equation. This is integral minus infinity to plus infinity minus of e raised to minus at u of minus t into e raised to minus st dt. Okay, so now u of minus t is the time reversal of u of t. Time reversal of u of t. That means this is called as the u of t. Okay, this is called as u of t. That is, the value of u of minus t is equal to 1 from minus infinity to 0. This is called as u of t, u of minus t. Okay, that means u of minus t is a time reversal of u of t when t is equal to minus infinity to 0. So I'm going to substitute that in this equation. I get the Laplace transform of x of t is equal to integral from minus infinity to 0 minus of e raised to minus at into 1, this u of minus t becomes 1 into e raised to minus st dt. Okay, this is also equal to minus of integral minus infinity to 0. Now I'm going to combine these two exponential function. I get e raised to minus a plus s t dt. Okay, this is that I'm going to get. So now I'm going to stop my problem and I'm going to find my R of C. So this is very easy to find my R of C over here. Okay, so as I said before, in order to determine the value of R of C, the power of the exponential function must be negative. This is the power of the exponential function. This whole term minus of a plus s into t must be a negative function, must be a negative signal, negative number. Okay, so how to find the value of R of C? Here, as you can see, since I said that the power must be negative, okay, the power must be negative. Don't ever forget that the power of the exponential function must be negative if you want to find the R of C. So here, if you look very carefully, there is already a minus sign over here. Okay, minus sign over here, and also if you look at the value of t, the value of t, this is integrating with respect to t, right? This is integrating with respect to t. So look at the value of t. The value of t is from minus infinity to 0. That means minus infinity, minus 500, minus 50, minus 10, minus 8, minus 7, minus 6, minus 5. All numbers are negative. That means the value of t over here is also negative. So that means this power that you see here is actually a positive value, because this minus sign and this t is also a negative value. So this negative value of t multiplied by this minus sign, this is actually a positive value. What you see here, this power of exponential function is a positive value. So if you want to find the value of R of C, then since this power is a positive value, then this equation, this value a plus s must be a negative value. Yes, that means from this we can say that a plus s must be less than 0. Right? The reason why we are getting this equation is because the value of t is also negative. In the previous problem, the value of t is positive. Here the value of t is negative. See, from minus infinity to 0. So the value of t is negative, and there is already a minus sign over here. So this minus sign with this negative t, you will get a positive value, right? So if you need the exponential power, the power of the exponential function to be negative, then a plus s must also be a negative value. So from here I can find my R of C. That is, my R of C is nothing but a plus sigma, or real part of s, must be less than 0. Or in other words, sigma must be less than minus A. This is my region of convergence. ROC must be less than minus A. Okay. So that means my region of convergence is from the value of sigma must be minus infinity to minus A. That's the meaning of this equation. Okay. Now I continue my problem as before. The Laplace transform of x of t is equal to minus of integral minus infinity to 0 e raised to minus of s plus a into t dt. Okay. So now this is also equal to minus 1 by s plus a into e raised to minus of s plus a into t from minus infinity to 0. Okay. This can also be if I want to remove this minus sign over here, I think it's better if you remove the minus sign. Okay, it's okay, let it be there. So this will become what? A positive value, right? So 1 by s plus a into e raised to minus of s plus a t from minus infinity to 0. Okay. So here I'm going to substitute my value. Here it is 1 by s plus a into here e raised to 0 minus. So look over here. Okay, here this is where many people might get confused. Okay, so that means everybody will think that if I substitute this minus infinity over here, then this becomes a minus of minus infinity, which becomes plus infinity, so this will become e raised to infinity. That's actually wrong, because you are forgetting about s plus a, right? So if you put a minus over here and this t also is minus infinity, so you will get plus infinity. But just simply look at the value of s plus a. S plus a is also a negative value, right? So here in this expression, there are 3 negative values. That is, this minus and this s plus a is also a negative value, and this time t is also a negative value, minus infinity. So in other words, here also we get e raised to minus infinity. Okay, because s plus a is also a negative value. That's why s plus a is also a negative value. So that negative value, with this negative value, this becomes a positive value. So minus infinity, if you substitute over here, you will get e raised to minus infinity itself. Okay, this is also equal to 1 by s plus a. Okay, so therefore the answer is the Laplace transform of minus e raised to minus at u of minus t is equal to 1 by s plus a. Okay, and its ROC is defined as the real part of s must be less than minus a. This is the ROC of that signal. Yes. So now if I want to plot the ROC in the s plane, okay, so I draw my s plane. Yes, the x-axis is sigma and the y-axis is JO. Okay, and now I'm going to mark my minus a. So let me mark this point as minus a. Sigma must be sigma. This is sigma, real part of s. This is sigma. So this must be less than minus a. So which means the value of JO can be anything, but the value of sigma must be less than minus a. So my region of convergence is this entire shaded region over here. Yes. So if you can see, the difference between this problem and the previous problem is that the answer is the same. The answer is the same, but the region of convergence is different. Okay? This is the answer.